All right, good morning, everybody. Welcome to reInvent. Welcome to our session. So you're all here because you need to build scalable, real-time gaming applications that attract and retain gamers. This is a challenge because creation of scalable, real-time, next-generation applications is not easy if you consider millions of concurrent users who are going to be using your systems at the same time. The concurrency and the millions of users and the data coming in causes a lot of churn within your applications, and you need robust architectures to deal with that. And to add to that pressure, you also need to create next generation applications, keeping in mind technologies like Web3, Metaverse, 5G networks, generative AI, blockchain, whatnot. So there's a lot of pressure here to create these robust architectures and solutions. So we are here to discuss a solution that will allow you to create that data solution, which is robust and can handle real-time applications. We will introduce you to Redis and as well as to Amazon MemoryDB for Redis. My name is Sashi Varanasi. I lead the in-memory and blockchain specialist essays at AWS. And I'm here with my partner.
Hello, everyone. My name is Roberto Luna. I also go by Robert. I'm a worldwide specialty solutions architect with in-memory databases, working with Elasticache and MemoryDB, which are our in-memory database services. I get to work with customers from all over the world and learn a lot from them, as well as giving them good ideas about how to build these super engagement and internet-wide systems. So happy to be here. Thank you for coming up on Monday morning.
Great, excellent, thank you. So here is our agenda at a glance. We'll start off with world of gaming, talk about gaming industry. We'll dive into some of the technical requirements you need to keep in mind while implementing and creating architectures for your applications. We'll play a fun game. Roberto will be on the stage to play an interactive game with all of you. Then we'll introduce the solution behind that game, talk about Redis and the built-in data structures that will simplify your application development, talk about the entire end-to-end architecture as well. And then I'll be back here to talk about generative AI use case for a gaming application, make it a bit more interesting with what's going on in the world today. And then I'll deep dive into Amazon MemoryDB for Redis, and we will leave plenty of time for question and answers, at least 10 to 15 minutes towards the end. So world of gaming. So as you know, gaming industry has been growing at a stunning pace. We have 3.1 billion people playing games. And there are certain technical requirements you need to keep in mind as you build for these audience. And I would like to mention that these are not just gaming technical requirements. If you are from different industry verticals and you're building enterprise applications that need real-time responses and that need to handle high volumes of data, then it's the same solution that applies to those enterprise applications as well. So it can be gaming application or it can be another enterprise application that needs high volume processing of data as well as real-time responses. It's the same architecture that behind the scenes that you will need to implement. So let's look at the gaming industry first. So according to this chart, which was provided by Newzoo, an industry insight here, gaming industry is a $200 billion industry in 2023. And it is growing at the rate of 10% year over year and will become a $350 billion industry by 2027. And if you look at the chart here, 50% of the gamers are mobile gamers. And then we have 30% of the gamers who are console gamers. So you have the majority of the gamers who are using your applications via mobile devices or via the console games. And these are millions of users, like we said. These are multiplayer games. There's a lot of concurrency and a lot of data that's coming in. So let's look at some of these requirements that you need to keep in mind as you build those applications. Global locality. So the first one is about you need to understand where your users are accessing your systems from. They can be all over the world, which means your application needs to be deployed across multiple different regions. So global locality is a must for these applications that span the entire world because they have users coming into their applications from all regions in the world. And then you have millions of requests per second that are coming in that we mentioned earlier. And all of these users are expecting instantaneous millisecond response times as they are interacting with your applications. And scalability is definitely, should be a built-in capability for your application in order to make sure your applications are cost optimized. For example, as your demand goes up and down, or as gamers join the game and get off of the game, you need to be able to scale up and down automatically. So scalability is definitely something that needs to be built into your architecture. And open APIs, because you need to interact with multiple different third-party APIs, other third-party applications, hardware, software, and whatnot. So you do want to expose open standard APIs in your applications. So that's a requirement to keep in mind. And they need to be innovative and transformational, like we talked about, because of the generative AI and other emerging technologies. You need to consider all of those into your architecture and the solution that you're putting together. So these are the requirements to keep in mind. And again, the underlying theme here is processing petabytes and zettabytes of data, as well as creating the robust data architectures and application architectures. And that's what we will cover in this session. Before that, we will kick off a fun game. And I would like to invite Roberto to come back.
Thank you. So let's make this a little bit more interactive. Let's play a real-time demo. It's just a quick demo. It's not intended for production purposes, but the whole idea is that we get to play with you and get responses in real time. So these are our little characters from the game. They will give you a hint to an answer for a question that we will be displaying on the screen. And be careful, they may give you or misguide you. So please scan the QR code here, and you will get to a page that will look like the one on the screen. Once you're there, you will be entering a nickname. Please don't put any personal information on it. Just try to have something like you will have on any other random game. I will be providing the pin in just a second. So please raise your hand once you're on this page. Excellent, thank you. It seems like most of you are coming up. I'll give it another 30 seconds. If not, once we're on the pin page, you will see the URL as well as the pin as well. So let me explain how this is going to work. We're going to get to this lobby page where you will see the pin ID that you will enter. This is not it. And then once you start coming up on the game, you will be added to this list. Once you're there, we would start the game. We will ask 5 questions, and then they will look like this one. Where are you in Vegas this week for? You will answer your questions. The question will only be on the screen, and you will only have like the colors of the answers that you can perform. And then at the end, we will see who the winner is. So let's go and play. That's the correct pin, so if you can please enter it. And once you start coming in, there you go. This is real time. So please raise your hand if you're already there so we can move on. Thank you, most of you are already there. Perfect. Excellent, lots of names. So we're gonna start 5 questions. You ready? First one, what are you in Vegas this week for? For fun? To go to the Sphere? For Rainbow 2023? Or just for the swag? Remember, there's only one correct answer. Yeah, you have a timer there. If you don't get your answered on time, we will just move on. Oh yeah, a lot of people came for fun in this sphere, but most of us came here for Rainbet. Thank you for answering. Great, that was quick. The faster the responses, the more points you get. What kind of database MemoriDB is? Yeah, we haven't talked about it, but let's see if you think it's SQL, key value, graph, or columnar. It is key value, perfect. Mori Kapu, all the way to the top. Great job. Now, what engine does MemoriDB supports? Redis, Memcached, etcd, or RocksDB? Thank you. Lots of questions, lots of answers coming up. Extra question, how many of you are familiar with Redis? Can you raise your hand? More than half, excellent, thank you. So yes, it is Redis. Mori Kapo, all the way to the top. Great work. There's a new names coming up. So what does EKS stand for? Extra Kubernetes Service, Elastic Kinesis Service, Elastic Container Service, or Elastic Kubernetes Service? It is Kubernetes. Excellent, thank you. It's mostly commonly known as EKS, but it's our managed version of Kubernetes. Yeah, new names coming up. Great, good job. Last question. What is the most popular game genre in 2023? FPS or TPS? Sports, strategy, or RPGs? I know, this is probably what you like, right? Yeah, it's very even, right? But this is FPS or TPS. Well, thank you so much for playing along. We have the scoreboard, and we have a list of winners. Congratulations, Morikapu. Thank you so much, everybody, for playing. Okay, sorry about that. Hope you had as much fun as I had building this game, and hope you liked it. At AWS, we believe using the proper tool to solve a problem. Finding the correct database for real-time applications is crucial to the success of your systems. We all know that only you know how to use a hammer, everything looks like a nail. So yeah, you can try to hammer your way around a screw, but you will probably better served by a screwdriver, right? Same thing with using technology to build your applications. The idea is that you use the proper tool, like in this case, Redis. It's an in-memory key value data store built from the ground up for extreme performance, low latency, and very specific use cases. Redis actually stands for Remote Dictionary Server. It is the #1 in-memory data store and the most loved database, according to DB Engines and the Stack Overflow survey. Mainly because it's blazing fast, super versatile, and is feature-rich and easy to use. Did you know all of these data types that Redis supports? Can you raise your hand? No? Do you know that supports almost a dozen different data types? If you don't, that's excellent. That's why you're here. Let me talk to you a little bit about them. So Redis, at the end of the day, it's a key value store. So you access your data via a key, and then you have a value. Those values themselves can be different data types. In this case, for example, Redis strings are the catch-all, right? It's a binary safe data type that you can put anything from plain text, binary data, and you can use it for pretty much anything. Bitmaps are just a subset of that, as well as bitfields. Hashes are a dictionary, essentially a data type that allows you to have fields and values within a meta key. If you think about it, this is like a Python dictionary or a single tuple of a relational database. Lists are the collections of strings that have order. Sets are a list of strings that have uniqueness. So this helps us maintain cardinality as well as membership. And sorted sets are a special type of sets that allows us to have a score associated to the unique members. This helps us to create rankings, and in this case, leaderboards. We have geospatial, hyperlog logs, and a couple more that are super interesting, such as Redis streams, that is an append-only log data type, similar to an Apache Kafka topic. So you can use this as a message broker, for example. JSONs are a nested, semi-structured data type that has name values, supporting numbers, strings, booleans, and other objects as well. So now that we have all these data types, can you raise your hand if you think that Redis is just a cache? Or do you think it's for something else? Can you raise hands for caching? No? Nobody? One? Two? Yeah, just a few, right? Indeed, Redis is more than a cache. It's a dictionary service that you can use for many other use cases. Of course, caching is the most prominent use case where you can cache data from a relational or any of these based system, as well as from APIs and other systems. But there's many other use cases such as session store, leaderboards, geospatial, chat and messaging, and like Sashi told us, a prominent overcoming with machine learning as well. But I would like to make clear that you can also use it as a primary database. We will talk more about MemberDB, but the idea is that you can use Redis as your primary data store for microservices and very specific use cases that require ultra-low latency, extreme performance, and linear scalability. Redis provides the functionality of having a cluster that the more shards you add, the more throughput you can get. So now let's talk about what we think our proposed solution for this pop quiz game looks like. This is a sample question of what we saw previously, where we have our gameplay. There's a question, that question has some answers, and then you play along with it. So there's 4 new characters coming to the play. These are our new friends. The first one being the quiz, which is a list of questions, right? The game itself, it's an event of the quiz. Then you have the players and the leaderboard. So let's dive deeper into that. Quizzes are a unique name and a category, and they have, like I said, a list of questions. In our case, we just have very simple questions. They were all just text, and we just had one correct answer. But if you think about it, you can have multiple different types of questions, and you can also have multiple correct answers. This is how our quiz looks like. It's super simple. It's the JSON data type for this use case because we do have a list of questions that we can expand, right? It's an array. We have our name, an ID, and a category. For this use case, we're using the JSON data type, which allows us to have those nested structures. The key itself, remember we said Redis is a key value data store. We use a key name, in this case, quiz, colon, and ID. And we will use the json.set command to store the data with the quiz ID and the string of the JSON. The game, it's an instance of a quiz, right? It's a point in time when we're playing this unique event. So there's one or more users playing the game, and they all interact at the same time. So that means that we have to have a point in time and a list of, or a set of elements. For this, we have what we call a hash. It's a Redis hash. In this case, because it's a flat schema, we don't need nested structures. So we have an ID, a host ID, the ping that you saw on the screen, as well as the status, etc. For the key name, we will use game, colon, and the ID. As you can see, I'm using the colon as the delimiter in all my keys to give some structure. For saving the values, I use the hmset command, followed by the key, and then the field or the list of field value pairs. This is the flow, so we will start the game, we will go question by question, wait for the answers, and then show the correct answer. Finally, show the results, and at the end, show the leaderboard. So the players are the actual users playing along the game. So they need to have a unique identifier as well. And they will be bound to a specific web host because we're using a WebSocket for this purpose. So there will be many game servers attending those players, but they will be bound to one by one at a time. So we need to identify them as well. They will have a total score and a rank. In this case, we're also using the Redis hash. It's a flat schema. We have an ID and the properties like the nickname. If you try to submit a nickname and that's already used for this particular game, you won't be able to succeed. You will need to try a new nickname. So the key is player, colon, and the ID. And we are using the same hmset command with the name player, colon, and the ID, and then the list of field value pairs. But remember, we said we need to maintain uniqueness for this particular instance of the game. For that, we're using a Redis set. Like we can see on the slide on the right side, we have a list of players. Those are the player IDs. So for that, we create a key called game, colon, players, colon, and the game ID. That's what gives us uniqueness. So we use the sadd command to add elements or members to this set. So this is the list of players into our unique game players key. Now that we have the gameplay and we like to keep track of who's winning more points like we saw on the demo, the idea is that you will keep the all-time score as well as the unique game that you play. And you can have even weekly, monthly, or anything that you like for that particular quiz. The idea here is that if you try to solve this with a relational database, you will find certain scalability problems, or any disk-based database for that matter. Because when you're touching the same key multiple times and you have high concurrency, you start facing problems. For the live leaderboard, we will use a sorted set. This data type allows us to maintain uniqueness as well as scoring for each one of those members. In this case, we are using the zset command and, the zintervie command with the key and the player as well as the points that they earned. The key name is leaderboard, colon, and the game ID. So as you can see, we're starting the game, so everybody has 0 points. The more points you get every time that you play, every round, we will be adding those to the sorted set. So as we keep going by, you can see that the next round keep updating the leaderboard, and notice how on the left side of the screen, there's a list of members and they're moving alongside in places. So by the end of the game, we see that the player BB2110B, it's all the way to the top, like we saw earlier. In this case, you have a gold, silver, and bronze user, so that's your podium. The idea here is that you will keep doing that zintervie to continually add points to the users, and then you will use the zrange command to get a list of top players, as well as the bottom, of course, if you want to. And the zrank to get the exact position of every member on the list of all the players amongst the game. So now let's talk about architecture design. How does the architecture look like behind the scenes? We will be using MemoryDB for Redis as our primary data store. Remember, you can actually use Redis as a primary database. For the compute, we're using Amazon EKS. In this case, we have multiple different containers that have a specific purpose. A game server that will be the one responding to your WebSockets and all of the requests coming in. We have a front end, that means that's the application that you load onto your mobile, and a game engine that interacts with MemoryDB and your game servers. When we do say, go to the next round, we use a Redis stream to send that message across, and it goes to all the game servers. We're also using Route 53 as well as ELB to manage incoming web requests. And all of the assets are coming from Amazon S3, fronted by Amazon CloudFront. We put all of our images of the code created in Amazon ECR, and then we created all of these using AWS Cloud9 as our web IDE. So let's dive deeper into what happens behind the scenes. First, when you load the front end. So there's a front end container that has the last version of the web application, and this is its own microservice, and actually doesn't even need a database. So this works by itself, right? You load your application, and that's it. Once you have, it's a single web application running from React. Now the game engine itself. You start the game, like you saw me when I created the pin. That's an instance of the game. So there's a WebSocket going to game engine to MemoryDB, and then that keeps moving along all the gameplay. Now the game servers, like I said, those are the ones that you interact with. So every time that you play or submit an answer, it goes to the game server. This submits the values to MemoryDB, and this also uses the leaderboard service to update the score in the sorted set.
Right. Thank you, that was excellent. So let's kick it up a notch here with generative AI. So we're going to talk about a high-performing gaming application that implements generative AI for non-player characters. I'm sure you all know what non-player characters are. Any popular non-player characters that you want to name here? Anybody in the audience? No? Okay. So these are the characters basically that are in the games that do not interact with the gamers when they're playing the game, but they do create an immersive, vibrant environment for the gamers. They make the game more interesting. In some cases, in the video games, these non-player characters, they dispense new information, or they may sell something in case you're creating a decentralized finance game where you're selling and trading things. So these can be the characters that are selling and trading in the game. Or they may be conversational. They may be talking with the gamers and having a conversation like a chatbot. But today, these, sorry, I think I went too fast. To go back. So these characters today are heavily scripted. So they are not really creating that immersive environment. It's not very vibrant. It's not captivating for the gamers because they are heavily scripted, and they are basically doing the same repetitive tasks. So what we can do here is introduce generative AI models behind the implementation of non-player characters. And before we dive into the solution for it, I wanted to cover a few basics about generative AI here. So there is something called in-context learning. And to understand in-context learning, let's understand a few more concepts about generative AI here. So as you know, generative AI is powered by foundation models. And these foundation models are basically machine learning models that are trained on vast amounts of internet scale data. And since they are trained on a number of data sets, they have a lot of knowledge that they have acquired. And they can provide answers in case of question and answer applications. They can provide certain information by reading the documents, do text summarization. So they can process a lot of data and provide different types of output. So there are models that are called LLMs, which are large language models. These models are capable of having dialogues. But as you know, all these foundation models are trained on the past data. So it's the data that already existed when they were training. What if you need to provide these models data from the current environment? So for example, if you want to make your non-player character more vibrant, more interactive, and speak like a human based on what's going on in the game right now, you need to provide the model that you're going to use behind the scenes, the data from the current environment. So the model has to automatically learn what's going on currently and what the real-time data is. And this can apply to enterprise applications as well. It doesn't have to be a gaming application. So if you're using a generative AI model for a chatbot for your enterprise application and you want to supply data to that model in order to provide a better response to the users who are interacting with your chatbot, you provide data using what's called in-context learning. So in-context learning is basically providing the current data, contextual data to the models so that the model is not only replying based on how it was trained, but it is also looking at your current real-time data in order to provide a much better response to your end users. And you can supply the data using two different methods to your models. One is short-term memory, which is like a caching service where you provide temporary data to your models, or you can provide that data using long-term memory, which is your primary database, which is your enterprise data source. So these two different methods can be used to provide contextual information to your model and get better responses from them. So that's what this diagram is showing, basically providing context awareness to the model to get better contextual information and better responses for the applications that are using generative AI models. So let's see how this will look for an NPC. So non-player character, basically here that I'm using is character that talks or has conversation with the end users. So what we're doing here is using Amazon Memory DB as a long-term memory solution and keeping all the observations that the NPC had earlier and all the reflections and the decisions it has taken as part of those conversations earlier as well. So this is the intelligence of the NPC that it kept in the long-term memory. And it also has other long-term memory elements such as the user information, the profile information, and whatever is needed in order to have a more meaningful conversation with the gamer who is using your application at that point. So as a conversational NPC, it's able to read all of this data and send users' question and the contextual information to the model to get a human-like response back with context awareness so that it can respond to the gamer. So that's the flow here. So the user asks the question, the NPC needs to respond. Before it responds, it gets the contextual information from the long-term memory, sends it to the model, and model responds with a human-like response, which is a human-like conversation that it can have, using the contextual information, and that response goes back to NPC, which interacts with the user. So that's one way you can make your game more captivating, more entertaining, and more human-like if you're creating an NPC with a conversation. And this would apply to any other enterprise application that may be creating a chatbot or anything else where you need to provide contextual information. This would be the solution that you would use behind the scenes. All right, let's deep dive into Amazon Memory DB for Redis. So holistic view of all of the in-memory databases that AWS has here. And these differ in the durability, and that's why we have the durability spectrum here. On the left side, we have the ephemeral data store, which is Amazon Elasticache for Memcached, which can be used to store the data that doesn't have to be permanently stored, any caching, static data, things like that. And then we have Amazon Elasticache for Redis, which provides semi-durability via backups and restore. That's also a Redis engine, so it has all those built-in data structures and advantages that you get by using Redis for gaming applications and other enterprise applications. Then on the right side, we have the durable Amazon Memory DB for Redis, which is our primary in-memory database that can be used for critical applications that need full durability. You can also use MemoryDB as a way to flatten the cache. So for example, if you have a durable database and you're currently using Elasticache on top of it, just for improving the performance, you can replace both the database and the cache by using Amazon MemoryDB for Redis, because you get the ultra-fast response times as well as the durability. So you don't need two databases, so you can consolidate your database architecture. So that's a durable database offering that we have. The core features, it's a fully managed AWS service. So it has integrations with CloudWatch, other monitoring and troubleshooting services. It provides full security compliance for your enterprise applications. And it provides 9 SLAs for critical applications that you're developing. And one thing that I definitely want to mention is data tiering, which is an innovation behind the scenes that we have added recently. And with data tiering, you don't have to keep all of your all of your data in memory. And as you know, memory is expensive. So what you need to understand within your application is what data needs to stay in memory all the time versus what data can be offloaded to an SSD. So data tiering will let you configure that so that you can offload some of the data into SSD and save cost by having smaller set of nodes for your primary in-memory database. So the way we achieved full durability for Amazon MemoryDB is by implementing what's called multi-AZ transaction log behind the scenes. So what this diagram is showing is that the writes are always synchronous into MemoryDB. So when a client sends the write, that write is persisted into the transaction log before an acknowledgement is sent back to the client. So that guarantees full durability into a storage for that write. And then that write, the written transaction is then propagated to the multi-AZ transaction log that's spread across different availability zones. So there's replication, eventual replication of that data, as well as the persistent that's guaranteed, providing you that full durability behind the scenes, behind Redis. All of the data is also in memory, and that's the reason why it can provide that ultra-fast performance. So we have microsecond read latencies here, single-digit millisecond write latencies because the data is updated in memory. And then it can provide that high volume transaction capability as well, with 100K writes per second, 360K reads per second per node, which is the R60 extra large, 16 extra large node that we've used for this test. So it can handle high volumes of data and provide the real-time latency, which is a requirement for real-time applications today. And it is built on Redis, so which means you have the same built-in data structures that Roberto covered in his session available to you, which will simplify the application development, especially if you're building location-based application, you have location APIs, you're processing a lot of data in memory for payment processing or any application that needs to process huge amounts of data and aggregate them, consolidate them. You have different data structures that can be used here to store all of that data. All right, so there are a few MemoryDB resources that I wanted to share. You can scan the QR code. We do have training sessions from training and certification, AWS training and certification courses that you can take on in-memory databases. We also have developer guides, user guides, and a number of different database blogs that you can access via AWS database blog portal. Number of different use cases that we have written about, and especially for MemoryDB, it is used as a microservices primary database because of the lightweight Redis engine behind the scenes. It also can be used as an asynchronous communication mechanism using queues for microservices. So there are multiple different use cases in gaming, fintech, many other industry verticals where you have real-time applications being developed. This is an app choice to use as your implementation for database. So with that, we conclude our session. I know we covered a lot here. We talked about the technical requirements for real-time applications. We shared the architecture behind the scenes for the gaming application. We also covered the generative AI use case, as well as the implementation for that application, and deep dove into MemoryDB. We can stick around and answer any of your questions. Feel free to ask. We'll be happy to answer.
There's a mic in the back.